Okay, we're doing an introduction into systems, which is basically solving systems by graphing. What you guys need to know is that a linear system, the definition of a linear system is just a fancy way, my definition is, it's basically saying more than one line, in this case because it's a linear system, more than one line on the same coordinate plane. And so if we're graphing more than one line on the coordinate plane, what do you think we'd probably be interested in? Justin? Yes, but in the sense that they do something. Joshua? Where they intersect. Yeah, so the solution to a linear system, is where the lines cross, if any, right? Because we know that there's a special case of lines that don't cross. What are they called? Parallel, right? And so when you guys, linear systems, when you guys get into econ when you're seniors, when you guys study supply and demand, all right, I'll give you guys a quick little example. You do not need to write this down. This is the demand graph, and this is the supply graph. Where they meet, this is what we call equilibrium, and that's where a company sets its price for toothpaste or for, you know, allergy medicine, whatever. If everyone in this class had allergies, I could theoretically elevate the price on my allergy medicine because you all demand it. Does that make sense? Okay? So that's basically a supply and demand graph based on a system, not necessarily linear, because as we know, things don't always move in straight lines. In fact, things rarely ever move in straight lines. Okay. Today we're going to graph to solve a linear system. I'll be honest with you guys, graphing is the least effective and least accurate method, Max, of figuring out where the two lines cross. But we just show it to you, that way you get a visual representation. I'll let you know right now, there will not be a graphing linear system problem on your quiz on Friday. But I gotta show it to you anyways. 2x minus 3y equals 7. 2x plus 3y equals 7. Now, before you guys go all A-team on me and tell me we can just use elimination, remember, technically you don't know that yet. So, right? So anyway, I want you guys to take a second and either give me x, y intercepts or tell me what these are in y equals mx plus b form. Go. All right, who can raise their hand and give me the top equation in slope-intercept form? Slope-intercept form of the top equation. Justin. 2/3 x? Yes. That is correct. Who can raise their hand and give us the bottom equation in slope-intercept form? Eric? Plus 7/3. Okay, so when we graph this thing, okay, 7/3 is like 2 and a little bit, right? So that's my yellow line. I'm going to move down 2 to the right 3, down 1, 2 to the right, 1, 2, let me just do this thing real quick. So I'm going to move down 1, 2 to the right, 1, 2, 3. Okay. Change colors for the next one. That was the, okay, so I'll do this one in red. So it's negative 7/3, so negative 7/3, and then up 1, 2 to the right, 1, 2, 3, right? Where's the point of intersection about? Anybody know who can approximate that point of intersection? Luke. 4, 0. About. The answer, if we were to solve it algebraically, would have actually been 7/2, 0. 7/2 is almost 4, right? It's like 3 and a little bit more, right? So it's almost 4. Notice how this is very inaccurate, yes? Okay? But you have to know a visual representation of what you're doing anyways. Questions on this at all? Any questions? Okay, let me give you guys one to do on your own. Okay. Want you guys to do this one. Y equals 1/2 x. Y equals negative 1/2 x minus 2. Go and take care of that one, please. Okay. Piece of cake, right? This one? Whoa. Okay, the top graph has a y-intercept of 0, 0, so it'll go up 1 to the right 2. Does that? Yes? Do we agree? Bottom 1, down 2, and then down 1 to the right 2. Who can raise their hand and guess that point of intersection right there? Where does that intersection point? Jared.
On mine, I got 2, -1.
2, -1? Anyone get something a little different? -2, -1? Yeah, -2, -1 is correct. Now, guys, listen up. I'm glad that happened. Because, what does that tell you about graphing? It's inaccurate, all right? It's inaccurate because it's just not that precise, okay? So keep that in mind. When we come back tomorrow, we'll do the algebraic, we'll do elimination, substitution, all that stuff. All right? Good for that? You have 2 problems from that section in your homework tonight.